Welcome back, everyone. In this lecture, we're going to begin learning about the very syntax basics for the Keras API for TensorFlow. Let's head over to a notebook and get started. Okay, here I am at the notebook. I'm going to begin with a couple of imports. We'll import pandas as PD. We'll also import NumPy as NP. And since we're going to be doing just a little bit of visualization, I will import Seaborn as SNS. Now, to actually focus on the syntax of Keras, for this particular lecture, we're going to be using a very simple and actually fake data set. And in the next lecture, we'll be using a realistic data set, and we'll focus a lot more on feature engineering. Let's go ahead and read in this file. We'll use pd.readcsv, and then underneath our data folder, there's a file called fake_reg for regression.csv. And then we'll check out the head of this data frame. So this data frame, it's very, very simple. It simply has a price and then two corresponding features. So we're going to treat this as a regression problem where based off feature 1 and feature 2, we'll attempt to predict the price. So we can imagine that maybe these are measurements of some rare gemstones where the gemstone has feature 1 and then feature 2, and we're trying to predict the price. So here we have historical information, which means this is a supervised learning problem. Our main goal is to build a model that when we pick a new gemstone from the ground, we can measure its features, feature 1 and feature 2, and predict what price we should be selling this at the market due to the fact that we have historical information on the price sold based off these two features. So a very simple data set. I want to quickly show you how we could explore this data set. We'll say, create a pair plot of the data frame, run that, and then we'll be able to see the features versus the price. And you'll notice that especially feature 2, it seems to have very high correlation with the actual price. So this kind of is another indicator that this is fake data. So in a realistic data set, which we're going to do in the very next lecture, we would take a lot of time exploring this data, doing what's known as exploratory data analysis, performing a lot of visualizations, as well as possibly performing some feature engineering, trying to extract other features from features that we can't quite use. However, let's focus really on the main workflow for using Keras and TensorFlow for deep learning. So step number 1 is to read in your data. And then once you have done feature engineering on your data, once you've explored your data, the next step is to create a test train split. And we can do this from scikit-learn's model selection has a train test split functionality, which is really easy to use. So what we're going to do is we're going to use this train test split function to split our data into a training set and a test set. So we'll train on the training set and then evaluate our model's performance on the test set. So first what we want to do is we want to grab the features that we're going to use. So in this case, that will be feature 1 and feature 2. And because of the way TensorFlow works, we have to actually pass in NumPy arrays instead of pandas data frames or pandas series. So I can simply add dot values to the end of a series or data frame, and it will return it back as a NumPy array. So what we're going to do is we're going to grab features and set that as X. And by convention, we use capital X because typically the feature matrix is two-dimensional. So we indicate that with a capital. And then the label that we're going to predict, our Y, is the price column. And same thing here, we'll grab values. And again, by convention, since the price is essentially a one-dimensional vector, we have lowercase y for that. So that's why we have uppercase x and lowercase y. It essentially stems from the way you would write this down mathematically on paper. So now that we have our actual NumPy arrays, so if we take a look at x, it's just a NumPy array of the same information we had in that data frame for feature 1 and feature 2. It's just NumPy instead of pandas. It's time for our train test split. So the way I like to do this is simply call train test split, and after you've imported it, you should be able to do Shift Tab to see the documentation string, expand on it, go ahead and scroll down, and eventually at the bottom you'll see something called examples. And to save myself a little bit of time, I like to just copy and paste this line from the example, which is essentially showing you how you would actually use this. So I'm going to paste that in and then put this all on one line and essentially explain what's going on here. Recall that when we do a train test split, we both split our features into xtrain and xtest, as well as our labels into ytrain and ytest. Make sure you review the machine learning section of the course in case you have any questions on what these four parameters or variables actually represent. Then for train test split, you pass in all your features as x, your labels as y, and then you choose a percentage as your test size. So typically you use maybe around 30% of your data. So if I said 0.3, that's going to be 30% of my total data will be used for the test set. And you can always make this smaller if you have really large data sets. And then there's the random state. So the train test split is going to perform this split randomly. So it's going to grab random rows and then split them into the training side and the test side. If you want to repeat the actual results of the split the same every time, then you would set a random state to a specific number. The number itself is just an arbitrary choice. You just have to make sure to choose the same one each time. So go ahead and choose random state is equal to 42, and that way you will get the same random split that I do. So we'll go ahead and run this. And now we've split up our data. And we can actually check this by checking the shape of this. So notice xtrain.shape is now 700 by 2 features, and xtest.shape is 300 by 2 features. So here's 70% of our data as a training set and 30% as a test set, since our total size of the original data was 1,000 rows. Okay, now typically the next step is to actually normalize or scale your data. Because we're working with weights and biases inside of a neural network, if we have really large values in our feature set, that could cause errors with the weights. And later on we'll talk about vanishing and exploding gradients. That could be an issue. But one way to try to avoid any issues when training your network is to normalize and scale your feature data. So scikit-learn actually allows us to do this quite simply by saying from sklearn.preprocessing import, and there's actually lots of different ways you can normalize or scale your data. One simple way is to use what's known as min-max scaling. So we'll go ahead and import min-max scaler, and if you call help on min-max scaler, it will actually describe what this is doing. So essentially, it's going to transform your data based off the standard deviation of your data, as well as the min and max values. So you can see here the actual formulation that it's running for us. So what we're going to do is show you how you can scale your data, which is very typical in your workflow for dealing with neural networks. Now, you don't have to actually scale the label, and if you take a look at our provided notebook, we have a link explaining why we don't need to scale the label. We really only need to scale the features, since that's essentially what's being passed through the actual network. The final label is just a comparison done at the end. So to use a scaler with scikit-learn, what we do is we first create an instance of it. So we choose some variable name, typically scalar, and then we create an instance of our min-max scalar, open close parentheses. So now I have this instance of this scalar, and what I'm going to do is I need to actually fit the scalar onto my training data. So I will say fit on xtrain. And what fit does is it simply calculates the parameters it needs to perform the actual scaling later on. So if we recall from calling help on min-max scalar, the min-max scalar is dependent on the standard deviation, the minimum value, and the maximum value within that particular data set. So what fit does is it essentially calculates the standard deviation, the min, and max. So that's what fit does. So we run fit on our training set. And the reason we only run it on the training set is because we want to prevent what's known as data leakage from the test set. We don't want to assume that we have prior information of the test set. So we only fit our scalar to the training set to not try to cheat and look into the test set. Then what we need to do is transform our training data. So we'll say xtrain is now equal to scalar.transform on xtrain. That actually performs a transformation. So there's essentially two steps here. We fit, which is calculate what's needed for the transformation to occur, and then we actually perform the transformation. And we'll do the same for the test set. So we'll say scalar transform on xtest. And now if we take a look at these values for xtrain, you'll notice they have been scaled. So if we take a look at what the max value on xtrain is, it's now 1. And then the minimum value is now 0. So everything's been scaled to now be between 0 and 1. And again, we're only fitting on the training set to not ascertain information from the test set because that's essentially cheating. Okay, so now that we've scaled the data, it's time to actually show you how to create your neural network. So in part 2 of this lecture, we'll begin creating our neural network. I'll see you there.